Welcome to Module 3, Drilling Rigs. By the end of this module, you should be able to describe what a drilling rig is, describe how drilling rigs work, identify the drilling equipment that is used, recognize the various types of drilling rigs, identify the locations in which they operate, and identify the well control equipment that is used. This module consists of 4 chapters. They are: what is a drilling rig, drilling equipment, types of rig, and well control systems. Each chapter will end with a short knowledge check to confirm your learning. Chapter 1. What is a drilling rig? A drilling rig is a collection of complex machinery that is used to drill into the Earth's crust to search for hydrocarbons. Although there are many types of drilling rig, they all carry out the same basic functions. Whether drilling for oil or gas, all rigs are essentially comprised of the same systems. Rigs are designed to work in many different environments. For example, on land, including deserts and jungles, and offshore, in swamps, shallow water, and deep water. Regardless of the environment, rigs must all perform the same basic functions. Chapter 2. Drilling equipment. In Module 2 we looked at how a well is drilled. To do this we need to be able to lift and lower the drill string, pump mud down the hollow drill pipe, clean the returning mud, and rotate the drill bit whilst maintaining control of the well. In order to do all of this, we require power. Each drilling rig, regardless of the environment, must have a well control system, which we will cover in more detail in later modules, power generating systems, hoisting systems, rotary systems, and a circulating system. In addition, each rig must have a drill string made up of various sections of pipe, which we also looked at briefly in Module 2. Let's take a closer look at the various systems on a drilling rig. Click on each component for a more detailed explanation. Crown block. A stationary assembly of sheaves or pulleys mounted on the top of the derrick that the drilling line is threaded through, running from the drum on the drawworks. Travelling block. Working in unison with the crown block, the travelling block also has the drilling line threaded through it, and together they give the rig its tremendous lifting power. Top drive. The top drive is a powerful electric or hydraulic motor that hangs from the travelling block and rotates the drill string. It enables drilling with 3 joint stands instead of single joints of pipe, and quick engagement of mud pumps. Drawworks. The primary hoisting machinery for lifting and lowering the travelling block, which takes the weight of the top drive and the drill string. Operated by the driller, drawworks can be driven by electric motors or diesel engines and can be used for many other lifting and pulling tasks around the drill floor. Mud pits, mud pumps, and shale shakers. The mud pits, or tanks, contain the drilling fluid, or mud, and the mud pump is a high-pressure pump used to circulate this fluid. Shale shakers are devices used for removing the drill cuttings from the mud returns that come back up the well. All this equipment is part of the mud circulation system, which we will look at in more detail shortly. A rig is equipped with draw works, a crown block and a travelling block, which, coupled with the derrick, allow the drill string to be hoisted. The two most common types of drilling method are top drive and rotary table and Kelly. Nowadays most rigs use a hydraulic or electric top drive to rotate the string. Older rigs use a Kelly and a rotary table. Many operations are carried out using a downhole motor to turn the bit. Here you can see a diagram of the circulating system. The closed mud system shown here is usually used in oil or gas drilling, as the only discarded waste is clean drill cuttings. Mud is pumped down through the drill pipe to the bit and returns up the annulus to the surface, through the fluid treatment equipment and back to the mud pits. We'll look at this in more detail on the next slide. From the mud pits, the clean fluid is pumped via the mud pumps and discharge line to the rig. Here it travels up the standpipe to the Kelly hose and down through the top drive into the drill pipe. The mud continues down through the drill string to the bottom hole assembly, where it exits via nozzles in the bit. Unwanted heat and drill cuttings are carried away from the bit face by the drilling fluid. The now contaminated mud is pushed back up the annulus of the well and exits via the mud return line at the top of the BOP stack. The return line deposits the drilling fluid into a hopper, known as the possum belly, which feeds it to the shale shakers. The fluid and small cuttings, sand, silt, etc., drain through the mesh in the shale shakers into the settling tank below. The larger cuttings are removed to the cuttings pit for later disposal. From the settling tank, the mud is pumped through cleaning equipment, which may include the desander, desilter, and centrifuge, to remove any fine particles before returning the now clean mud to the active mud pit. The components of a drill string will vary depending on individual requirements, but for the purpose of this training we will focus on the main components found in all drill strings. The lower part of the drill string is collectively referred to as the bottom hole assembly, or BHA, and extends from the drill bit to the drill pipe. The BHA consists of many different components, including the drill bit, bit sub, stabilizers, drill collars, drilling jars, and heavyweight drill pipe, all joined together with screw threads. The drill pipe connects the BHA to the rig surface equipment. These hollow pipes transmit rotary motion and drilling mud under high pressure down to the drill bit. Unlike using an electric drill where you have to push on the drill, the weight of the BHA generates the force to penetrate the rock formation. The rest of the drill string will be in tension. The major part of the drill string is made up of drill pipe, which allows mud to be circulated and transmit rotary motion to the bit. Nowadays, each joint of drill pipe is normally around 30 feet in length and will be hoisted in and out of the hole in stands, which refers to 3 joints joined together. Drill pipe is surprisingly flexible. Typical sizes can be seen on the table shown here. Drill collars provide the weight required to drill. There are 2 main types of drill collars, slick and spiral grooved. Both accomplish the same task of adding weight to the bit. However, spiral grooved drill collars help to prevent the drill string from getting stuck in the hole by allowing drilled cuttings and fluid to pass more freely around the collar. Typical sizes can be seen on the table shown here. As you can see, drill collars are much heavier than drill pipe. The length of the BHA is calculated to ensure the rest of the string is in tension. Measurement while drilling tools have been developed to constantly feed back information from the bottom of the hull, including direction, formation properties, and downhole pressures. Combined with mud motors or turbines, close to the bit, adjustable stabilizers and MWD tools allow very accurate steering of the direction of the hull. Heavyweight drill pipe is thicker walled than standard drill pipe, but lighter than drill collars. It provides a transition between the flexible drill pipe and the stiff bottom hole assembly, gives extra strength, and helps prevent buckling. As discussed in Module 2, there are many types of drill bits, designed for different formations and cost effectiveness. Chapter 3. Types of rig. Although all drilling rigs perform the same function, there are many different designs. They can be broadly categorized as those supported by contact with the surface of the earth, either on land or seabed, and those which float. The different types of installation include land rigs, swamp barges, jack-up rigs, semi-submersibles, drill ships, and fixed platforms. Let's take a look at these in more detail. As the name implies, land rigs work on dry land. A site is cleared and the rig and equipment moved in. Land rigs can be adapted to work in the desert or the Arctic, and even soundproofed for use in urban locations. Land rigs range from light duty to heavy duty. Light duty rigs are quick and easy to move, but are limited by the depth they can drill to. Heavy duty rigs can drill much deeper, but are much more difficult to move from location to location. Not designed to withstand the waves and movement of open waters, swamp barges are extensively used on inland waterways, where they use anchors to position and steady themselves for operations, and some may even partially sink themselves to sit on the bed of very shallow waters ready to drill. Most drill barges are towed into position and generally operate in places such as river estuaries, swamps, and lakes. Jack-ups are mainly used in shallower waters, with some able to drill in water depths of up to 450 feet. Jack-ups are generally towed to location, but can also be lifted onto large, specially designed ships and sailed to the drilling site. Once on location, the legs are lowered to the seabed, then the hull is raised to just above sea level and loaded to the maximum weight to ensure the spud cans, or cylindrical steel shoes, are securely planted on the seabed. The hull is then elevated upwards and away from the maximum anticipated wave height. Many jack-up rigs have cantilever decks, which are extended from the stern of the hull when the rig is jacked up, and which can be accurately positioned by adjusting backwards, forwards, left and right. Semi-submersible rigs float upon a number of steel pontoons that allow them to be towed, lifted, or even sailed under their own power to location. Once in place, the semi is ballasted and partially sunk, and because the large pontoons then remain underwater, it becomes much more stable and is held in position with either anchors or dynamic positioning. Generally, they are capable of drilling in water depths between 300 and 4,500 feet. Being self-propelled with streamlined hulls, drill ships are often used in very deep or remote waters where it would be impractical to use tethered rigs such as semi-subs. Drill ships are also dynamically positioned and are faster and easier to move than rigs. At maybe 800 feet long and 6 stories high, drill ships can carry large amounts of equipment and have less requirements for support and resupply. Any floating drilling system is going to face the challenge of keeping a constant weight on the drill bit when the vessel is moving due to tidal and wave conditions. As the drill bit is connected directly to the rig floor, this means that it will be moving relative to the bottom of the hole. All floating rigs have systems known as heave compensators. Heave compensators are extremely large air-powered hydraulic jacks that change the distance between the travelling block and the crown block. They move instantaneously relative to the vertical movement of the drill ship or semi-sub. You can see the vessel movement and the way the heave compensator adjusts for this, maintaining the same weight on bit at the rig floor and no movement of the drill bit from the bottom of the hole. As the name suggests, fixed platform rigs are placed upon a fixed production platform with a frame-like structure or a central column with huge foundations set onto the seafloor. This rig type is usually meant for long-term drilling and production, or is used where numerous wells are required from one platform. Rig equipment on a fixed platform allows for the existing wells to be worked on. Chapter 4. Well Control Systems. We will discuss well control systems in more detail in later modules, but for now it's important to know that all drilling rigs have well control equipment and systems. Firstly, some definitions in relation to well control. Primary well control. In drilling, this means controlling formation fluid pressure by means of the hydrostatic pressure of the drilling fluid. This might also be referred to as the primary barrier. Secondary well control. If the primary barrier fails due to an increase in formation pressure or a decrease in hydrostatic pressure, then well control equipment must be used to contain the pressures and allow primary well control to be regained. As we have discussed, the primary barrier is the column of drilling fluid in the well. Failure to maintain this barrier can result in an influx or kick. On a drilling rig, the secondary barrier refers to the well control equipment. This is made up of blowout preventers, often called the BOP Stack, the blowout preventers control system, and the choke and kill manifold. On a bottom-supported rig, this equipment will be placed at or near the rig. On a floating rig, it will be located on the seabed. The importance of this equipment is paramount to prevent an influx or kick becoming a blowout, with the consequential risks to life, environment, equipment, and the reputation of our industry. While the exact nature of the equipment differs between rig types, there are many common factors. A BOP stack typically consists of an annular preventer and at least 2 or 3 ram-type blowout preventers mounted on the wellhead, which provide secondary well control in the event of a kick. The configuration of the BOP stack will depend on the type of well being drilled and the current regulations. All rigs have choke and kill lines, so that in a well-controlled situation, fluid returns can be directed to the choke manifold to allow pressure to be controlled. We'll look at this in more detail later on. The blowout preventer is designed to shut in the well to prevent a release of hazardous formation fluids at the surface and allow primary well control to be regained. The elements of a BOP stack consist of the annular preventer, which contains a large rubber or elastomeric ring which is squeezed inward to seal around the pipe, closing off the annulus. This has the ability to seal around a variety of pipe sizes. Ram-type preventers consist of 2 steel blocks that are forced together by hydraulic cylinders to seal off the wellbore either with or without pipe. There are generally 3 types: pipe, blind, and shear. Pipe rams are designed to seal around specific sizes of pipe with the aid of rubber components, closing off the wellbore. Variable bore pipe rams are designed to seal on a range of pipe sizes. Blind rams are designed to seal off the well completely when it does not contain a drill string. Shear rams are fitted with hardened steel blades that are designed to cut through any pipe when the BOP is closed to seal the well and therefore allow the blind rams to close. Some BOPs have combined shear and blind rams, referred to as blind shear rams, designed to cut through any tubulars in the BOP and then fully seal the well. Operation of the annular and ram preventers is from the BOP Control Unit, where the hydraulic energy required to open and close the blowout preventers is produced and stored under pressure in accumulator bottles. Controls for this unit are usually located both on the rig floor and in a safe position away from the rig floor. Once the kick has been detected and the well safely shut in with the appropriate BOP, returns will be directed via the choke line to the choke manifold. The choke manifold consists of a range of different valves through which, in the event of a kick, pressure can be controlled, preventing further influx and allowing hazardous fluids to be disposed of safely. An important part of the well control system is the mud-gas separator. During well control operations, the gasified mud will be directed from the well, through the choke manifold and into the mud-gas separator. This is a large vessel which allows mud to be returned to the mud pits and gas to be vented to the atmosphere. Valves may be installed in the drill string to prevent any formation fluids entering the pipe in the event of an influx. Well done! You have reached the end of this module. You should now be able to describe what a drilling rig is, describe how drilling rigs work, identify the drilling equipment that is used, recognize the various types of drilling rigs, identify the locations in which they operate, and identify the well control equipment that is used. Thank you for completing this training module. We hope this will help you in your workplace. Remember, you can revisit this module at any time to refresh your knowledge.